Hello and welcome to this video. This is my website called The Headlines, and today I'm going to show you how I add content. We have a load of articles categorized in these topics: tech, science, finance and policies. I'm the only admin, so when I log in I get access to the admin dashboard. I have the create, review and images. So the way I create an article is I go to the create tab, and I have three different methods of creating an article. I can use an RSS feed, I can research my own thought up topic, or I can put a YouTube video in and specify time codes of a particular YouTube video. So today I'm going to concentrate on RSS sources. I researched into finding a whole load of RSS sources that I find are reliable and would provide good news for my website. I actually did the research in Perplexity, where I asked it to find me reliable tech news RSS feeds. I had a session where I just went through all these sources, picking out what's going to be the best news topics for my website. The topics that I'm interested in is science, finance, business, and tech. I also wanted to find RSS sources that provided open articles that weren't behind a paywall. So back into my website, I'm going to look for an article to publish today. So I go into the TechCrunch News RSS source, and these are the last refreshed sources from this RSS feed. I have a feature here where I can refresh them. Okay, now we have an up-to-date version, and I just go through and I find what's interesting. After 9 years of grinding, Replit finally found its market. Can it keep it? Amazon to resume drone delivery following crash in Arizona. Department of Energy cancels 7.5 billion of clean energy projects in mostly blue states. Anthropic hires new CTO with focus on AI infrastructure. OpenAI Sora soars to number 3 on the US App Store. YouTubers aren't relying on ad revenue anymore. Here's how they're diversifying. That's interesting. Okay, so there's a few interesting ones. I'm going to pick one. I'm going to go with this OpenAI Sora. It seems to be big news at the moment. So this is the actual article. So this, I'll count this as a source article. It's in TechCrunch. And what I do, I use a checkbox to select it. I add it to my queue. Here we are in Cursor, and I want to walk through exactly what happens when you check those boxes next to the RSS articles and click add to queue. This is the function that makes it all happen. It's called add RSS matches to queue, and it's a convex mutation. First, let's look at what this function accepts. It takes two things: a source ID. This is the ID of the RSS source you're working with. It's typed as v.id, which means it must be a valid ID that points to an RSS source in our database. Then there's the selected articles. This option is an array of article objects, and each object has 4 properties: title, URL, description, and publish date. Now let's have a look at the function step by step. First thing is we grab the RSS source from the database using that source ID. Then, if the source doesn't exist, we throw an error. Next, we figure out which articles to add to the queue. This line says, use the selected articles if they were passed in. If not, use all the matched articles from the source. If there's nothing at all, just use an empty array. We need to figure out what category these articles belong to. If the RSS source is set to load all articles mode, meaning it's not filtered by keywords, we just label it as all no filter. Otherwise, we fetch the actual category from the database using the category ID. If for some reason the category doesn't exist, we fall back to unknown. Now for the main event, the loop. First, we create an empty array called queueItems to keep track of what we're creating. We're also grabbing the feed URL from the source, checking feed URL first, then URL as a fallback, or just unknown feed. Then we loop through every article in the articles to add. For each one, we insert a new record into the create queue table. So as you can see, we can do multiple articles, even though in this example, I'm only choosing one. Let's break down what we're inserting for each queue item. Title. The article's title straight from the RSS feed. URL. The article's URL where the original story lives. Concept. This is the article's description from the RSS feed. This becomes the concept that the AI will use as context. Concept. This is the article's description from the RSS feed. This becomes the concept that the AI will use as context when it processes the article. Category. The category name we figured out earlier. Create source. A string that says RSS followed by the feed URL. This lets us trace where the article came from. Status. Set to pending, meaning it's ready to be processed. QDAT, the current timestamp, is processing. Set to false, not being processed yet. Processed, also false, hasn't been processed yet. After inserting each one, we collect the ID in our queueItems array. Once the loop finishes, we log a success message to the console. If selected articles was passed in, we say selected, otherwise we say matched. So the log message adapts based on how the function was called. Finally, we return a success object. This tells the UI that everything worked, how many articles were added, and gives back the array of queue item IDs. And what the queue does, it kind of universalizes all the information into just a title, a concept, the actual article if there is one, and a category if there is one, and the actual source. So you can see it's pending here. I'm going to process this. I'm going to do one at a time just to show you clearly how I get from an RSS feed to a finished article. So now it's processing. This function called process with AI internal takes those raw RSS articles and transforms them into fully fact-checked, well-written articles using Perplexity AI. First, let's look at what this function receives. It has a title from the RSS feed, the URL from the original article, a concept it belongs to, and create source where it came from, like RSS TechCrunch. It also gets a Convex context CTX so it can query the database. The function returns a promise, processed article, an array of fully processed articles ready to be published. First thing it does, count how many items were processed and log it. Notice that little ternary operator. If there's one item, it says item. If there's more than one, it says items. Nice touch, eh? Then we check for the API key. Now we fetch all available categories from the database. Because we need to tell the AI what categories exist in our system so it can categorize the article correctly, we map through all the categories and extract just the names into the array. Building the content section. Here's where we format the queue items into a structure that AI can understand. We loop through each item with map, and for each one we create a formatted text block that says article, the title, the description, the source, the URL, and the category. Then we join all these blocks together with new lines. So if we're processing 3 articles, we'll have 3 formatted blocks, one after the other. Now for the big one, the prompt. This is massive, carefully crafted instruction set that tells Perplexity AI exactly what to do. And it's here in the const prompt. First, we set the role, you're a professional tech journalist. Then we give it the original content we just formatted. And then the task. Process each article individually and return an array of processed articles. For each article, Use your research capabilities to find 4 to 10 reputable sources reporting on the same story. Fact check the key claims against these sources. Write a well-balanced journalistic article that synthesizes the information. Identify any conflicting reports or uncertain details. Create a compelling excerpt. Generate 3 detailed image generation prompts for visual content. Next up, the requirements for the article itself. The title must be under 10 words, make it short and snappy for easy reading. Articles should be 4 to 800 words. Use professional objective tone, include specific facts, dates, figures when available. Cite discrepancies between sources if they exist. Focus on factual accuracy over sensationalism. Now here's something really interesting, the image generation prompt requirements. This section is huge because generating good AI images requires very specific instructions. Create 3 detail specific prompts for AI image generation. Each prompt should be 50 to 150 words with rich descriptive detail. Realistic imagery, focus on photorealistic cinematic quality rather than obviously AI generated looks. Specific people. If article mentions famous figures, create realistic portraits in appropriate settings. At the moment, DALL-E 3 doesn't make images of famous people. Scene recreation for events, riots, protests, disasters. Recreate realistic scenes with attention to lighting, composition, atmosphere. Scientific content. For research, science articles, create detailed microscopic imagery, abstract compositions. Technical detail. Include specific camera settings, lighting conditions, color palettes, composition techniques. Contextual settings. Place subjects in environments to enhance the story narrative. Avoid generic stock photo looks, obvious AI artifacts, cartoonish elements. Style direction. Professional photojournalism, documentary photography, cinematic lighting, editorial photography. We don't want generic AI looking images, we want photorealistic, professional looking imagery that actually relates to the story. The prompt even gives example formats. I have some prompt examples here as well for the 3 different types of prompts. Markdown formatting. The prompt also specifies exactly how to format the article in Markdown. Start with one introductory paragraph, follow exactly 3 subheadings, use triple hash format for subheadings. Each section under subheading should be 2 to 3 paragraphs long. Break into new paragraphs every 2 to 3 sentences at neutral narrative breaks. Write a natural journalistic style with smooth transitions between ideas. Make subheading titles highly specific to the actual story content rather than generic categories. So the structure is intro paragraph, 3 sections with specific headings like Tesla, new battery technology, not generic ones like overview or analysis. Source citation. Here, we want inline citations that are clickable, numbered, and bold. They should appear right where the claim is made, not at the end of the article, and they need to match the sources in the source URLs array. Source data requirements. This creates structured array for sources so that we can display in the UI. And finally, we tell AI exactly how to format its response as a JSON array. It dynamically inserts the available category names so AI knows which categories are valid. If we're processing multiple articles, it shows the structure for multiple objects in the array. Now we actually call Perplexity API. Here we use Sonar Pro model. We set the temperature to 0.2 for more consistent, less creative responses, and allocate 8,000 tokens per article so it doesn't get cut off. The system message reinforces only return JSON, nothing else, and the user message includes our full prompt plus a critical reminder about the exact number of articles and format expected. Passing the response. Once we get the response, we need to pass it. We get the content from the first choice, then we check, does it start with a square bracket or a curly brace? If not, the AI might have added extra text, so we use regex to find the JSON array or object within the response. If we can't find any JSON at all, we throw an error. Then we pass the JSON. We try to pass it as JSON, If it's an array, great. If it's a single object, we wrap it in an array to normalize it. If parsing fails, we check if it looks truncated by looking at the proper closing bracket. If it seems truncated, we add a helpful message suggesting to process fewer items at once. Final validation. After parsing, we validate each article. We loop through each process article and check, does it have a title, body, and category? Those are required. If any are missing, we throw an error. For image prompts, we just warn and set an empty array if they are missing, not critical enough to fail the whole process. Return and error handling. Finally, we return the process articles. If anything goes wrong at any point, we catch it. We log the error and throw a new one with a clear message about what failed. Okay, so this is what happens. Once it's finished processing, it disappears from this queue, and it then appears at the top. Here it is, at the top of my review tab. I go to review. I've got pending. This is the first one. I can open it, and what I have to do now is I have to review it. I'm going to check the sources, and then I'm going to add an image. So if we go into preview mode, I check every source because sometimes Perplexity gives back 404s. It mostly happens when I do more than one article at a time, so I'm hoping not sure what's happening here. Let's try another one. Okay, this one works. Benzatine. And it's on topic. Let's see, Guru Focus. TechCrunch, that was our original source. Apple.com. Okay. It's all apart from Tech Buzz. Let's try again. Okay, for some reason the Tech Buzz article is not loading. It's either offline or Perplexity's created a fake link for that, which happens sometimes. That's why I have to check them. So now this is a good opportunity to go in to edit. So this is just how it's going to look on the website. These are the markdown formattings that I then manipulate with HTML inside my program. And if we're going to edit, this is where I can edit everything. So now what I want to do is I want to delete that first source. And as you come back here, we just check, okay, it's been deleted. Now I want to add an image, and I'm going to go into this add image flow, which is I send a prompt via OpenAI API to DALL-E 3 to get an image back. And I'm going to look at, if I go to edit prompt, these are all the 3 prompts that Perplexity has sent back while making the article. Wide angle photorealistic of young diverse group of people using smartphones bustling in the park. Okay, close-up cinematic portrait of user interacting with Sora app on their phone. Editorial style over shoulder of tech journalists analyzing Sora's app store, ranking on the laptop. Okay, let's try this first one. Okay, so just generate image. Right, so when you press that generate image button, this is what happens on the back end. We've got our AI generated article with detailed image prompts, and now we actually want to turn those prompts into images. This is the function that does it. Generate image with DALL-E. First, let's look at what this function accepts. On the arguments here, we've got a prompt, which is a v string. It's a convex action, not a mutation or query, because it needs to make external API calls. Actions can call third-party APIs, which is exactly what we need here. The only argument is a prompt, a string containing our detailed image generation prompt. Remember those 50 to 150 word prompts that AI generated? This is where I use them. API key check. The first thing the function does is check if we have the open API key. If no API key, we can't proceed. If it's missing, we log an error and throw an exception immediately. Next, we validate the prompt itself. First, there's two checks here. Length check. OpenAI has a limit of 1000 characters for DALL-E prompts. If ours is longer, we throw an error. Empty check. We use .trim to remove whitespace, then check if there's anything left. Empty prompts aren't valid. Then we log the first 100 characters of the prompt so we can see what we're generating. Now for the main event, calling the OpenAI API. Let's break this down. The model is DALL-E 3. We're using DALL-E 3, the latest model. Prompt args.prompt, our detailed image generation prompt. N1, generate one image. DALL-E 3 only supports one at a time anyway. Size 1792 by 1024. That's 16 by 10 aspect ratio. It's the closest that DALL-E has to 16 by 9 widescreen, which is what I originally wanted. Quality, standard. Could be HD, but standard is cheaper and usually good enough. Response format, URL. Give us back a temporary URL to download the image from. The authorization header uses our API key with bearer authentication. Response status. Right after making the call, we log the response status in this console.log. This helps us debug if something goes wrong. We'll see the HTTP status code in the logs. 200 for success, 401 for auth issues, 429 for rate limits, etc. Error handling. Now, here's the sophisticated part. If the response isn't okay, we don't just fail generically. We start with a basic error message using the status code. We try to pass the error response as JSON to get more details. We check for specific error codes. Invalid API. Insufficient quota. You've hit your spending limit. Content policy violation. The prompt violates OpenAI's content policy. It's either too violent or explicit. Otherwise, we use whatever error message OpenAI gives us. This gives users actionable error messages instead of cryptic API responses. Okay, now onto the success response. If the API call succeeds, we pass the response. OpenAI returns the image data in a nested structure, data.data 0. We do a safety check. If any part of that path is missing, something went wrong and we throw an error. If everything looks good, we return an object. Image URL, the temporary URL where DALL-E hosted the generated image. Success true, a flag indicating generation succeeded. Finally, we have a catch block for any unexpected errors. If the error is an instance of error, which it usually is, we just rethrow it with the original message. This preserves our detailed error messages from earlier. It's kind of right, because it's obviously AI, and it is about, what's it about? It's about Sora, which is an AI video app from OpenAI. So I'm going to go with it. I'm going to rate it a... And notice he's even got loads of fingers. I might just keep that. Or weird hands. What I'm going to do, I'm going to edit the prompt a bit. I think this shallow depth of field is not needed. Editorial documentary style reminiscent of Peter Yang, conveying excitement and digital connectivity. Okay, I have no idea what that means, but I'm going to save it and I'm going to generate it again. just to see what it comes up with. Okay, that's pretty cool. I like that. That's better. The hands are more hidden as well, and it's weird and wonderful. Okay, good. I'm gonna rate it a good. Yeah, let's rate it a good. Okay, I'm gonna save that. Right, so we've generated the image. Now, how does the image go from DALL-E to our Cloudflare R2 bucket to our database? All linked to the article. Let's spend a little time and just walk through this flow. DALL-E generates the image and gives us a temporary URL. We download that image from DALL-E's server. We upload it to Cloudflare R2 for permanent storage. We create a database record in Convex, linking everything together. We optionally attach it to the article. This all happens in about 10 to 15 seconds. So let's break down each piece, starting with downloading the DALL-E image. Right, so after DALL-E generates the image, we have a temporary URL that expires in about an hour. So we need to grab that image fast. And here's the function that does it. Download and upload to R2 in the lib folder in a file called cloudflare.ts. Okay, so it takes two arguments, image URL, that temporary DALL-E URL, and original file name. First thing it does, download the image. Simple fetch request. If it fails, we throw an error for the status text. Then we convert the response to a buffer. We grab the array buffer from the response, convert it to a node.js buffer, and extract the content type from the headers. If there's no content type, we default to image/png. Step 2, uploading to R2. Now we've got the image as a buffer in memory. Time to upload it to Cloudflare R2. This calls another function, upload image to R2. Let's look at what upload to R2 does. We export async function, upload image to R2. It takes the buffer, file name, and content type. First, it generates a unique key. The key is the path to the R2 bucket. It sanitizes the file name by replacing any special characters with underscores, adds a timestamp to make it unique, and prefixes it with images/. Now for the actual upload. Cloudflare R2 uses S3 API, so we use AWS SDK. Let's break this down. Bucket, your R2 bucket name for environment variables. Key, the path we just generated. Body, the actual image buffer. Content type, image/png. Cache control, cache for 1 year. Metadata, custom metadata, when uploaded and that it came from DALL-E 3. We send the command to the S3 client, which uploads to R2. Okay, now on to step 4, generating the CDN URL. The CDN base URL comes from your environment variables. We append the key to create the full URL. We log everything for debugging, then return both Cloudflare URL, the public URL to access the image, Cloudflare key, the internal key for R2 operations like deletion. This return value goes back to the upload API route. Okay, step 5, the upload API route. Let's look at how the upload API route handles this. We have an export async function, which is a post request using next request. It receives the DALL-E URL in the request body, validates that it exists, calls our download and upload function, and returns the Cloudflare URL as JSON. The front end gets this response and now knows where the image is permanently stored. Step 6, creating the database record. Now we need to save this to the database. The front end calls the convex mutation, create image, in convex/images.ts. So we go back to convex and it's images.ts. Now we need to save this to the database. The front end calls the convex mutation, create image. So this takes article ID, which is article this image belongs to. prompt ID, which prompt has used to generate it, Cloudflare URL, the public CDN URL we just got, Cloudflare key, the R2 key for storage operations, model, which is DALL-E 3 in this case, generation costs, optional cost tracking. It's about 4 cents per image. We fetch the article and its category because we're going to store the article title and the category ID directly in the image record. Step 7. Inserting the image record. Now we create the image record. We insert this record into the images table and get back the image ID. Return it to the front end. Step 8. Linking to the article. Okay, at this point the image exists in R2 and in the database, but the article isn't using it yet. In the edit article flow, there's usually another step where you select this image as the article's main image. That would be a separate mutation like await ctx.db.patch article ID. This sets the image ID field on the article record, creating a link. In this update image metadata is where the image exists in the R2 and the database, but the article isn't using it yet. In the edit flow, there's another step where you select this image in the article's main image. So that is this mutation here. This sets the image ID field on the article record, creating the link. Now when you query the article, you can fetch its image. Okay, so saving this image now links it to this article. It saves it in my R2, my Cloudflare R2 bucket here, and it also links it to the actual article, which is here. Okay, so that's saved and linked. This is exactly how it's going to look like on my website. So to get it on my website, I just press approve. And now it moves from the pending tab into the approved tab. Now all these articles in the approved tab, these are the only articles on my website. I have loads in pending. I haven't got to make all these yet. They're kind of interesting articles I've seen and processed, but I haven't put an image to them and I haven't read through them and I haven't approved them. Rejected, these are ones that I want to delete, that didn't work, that failed, something happened to them, weren't quite right. I have saved for drafts in case I want to save for later, but at the moment we're concentrating on this approved tab. So now if we go back to the headlines, there it is, it's live on the website. I'll open it up, and then to get back to the home page, I haven't got a nav bar, I just got this simple close button that goes back, and that's it. Thank you for watching.